So the thing to understand about histograms is that it is the area that corresponds to the frequency. So once we know it's the area that corresponds to the frequency, really that's how you can work everything else out. So um, and it also understands why we call this frequency density. If the area equals the frequency, then that is also equal to the width, otherwise known as the class width, the width of the bar multiplied by the frequency density. So rearranging that, we can say that frequency density is equal to the frequency divided by the class width. So this is where this idea of density comes in. It's like the frequency per width, I suppose. So what we need to do is we look at each one of these and we identify the class width. In this case, it's 30, that's 10, 10, 20, and that's 30. And then we calculate what the frequency density would be such that the area of the bar that we end up drawing is would be equivalent to the frequency when you multiply the width by the height. Okay, so we'll just pause the video, we'll have a quick go at that. So what we've done is we've just divided the frequency by the class width. So this was 30, 10, 10, 20, 30. I'm just simply looking at the range between the minimum and the maximum there. And then do the frequency divided by that, and we get these numbers here. So these are going to be the heights of our bars. And then we just got to make sure the width corresponds to this range of numbers here. Okay. Yeah, that's right. So we can see now that the most amount of people are between sort of 30 and 60, 30 and 70, right? So what histograms enable us to do is kind of imagine a sort of how the total amount of what is this? This is total amount of students are arranged. So it kind of forms a kind of bell curve like this, and so then the total area of all of them added together would be the total amount of students in this case. Okay, so I will pause the video. I will stop the video there and save it around about here.